we have got literally probably 8 to 10 times the lumens that we had in this space before. Hey, this is Joel Walsman, CEO, Master Electrician of Jefferson Electric. We're back to our off-grid shop. In this video, you're going to learn how to wire the lights. We've got these 14 overhead lights already wired up, and we're going to show you in this video how to add these two. You're going to get all the steps, all the nuts and bolts, and at the end, you're going to be able to do it yourself. We've been wiring it step by step, demonstrating receptacles, panels, feeders, circuit sizing, feeder sizing, and today we're going to be continuing on our lighting. Now, in our absence, the guys have gotten a lot done. We've got 2 rows of a total of 14 fixtures. These are LED 8-foot strip fixtures. And it's bright out here. It's beautiful. It's so much better and beyond than what we had. We've got a great distribution of light. And I'm going to highlight some of the different tips and tricks and the tactics with which we approached the lighting portion of this project. Number 1, lighting by definition is considered a continuous load. Continuous load is a very important code concept, and that means something that operates under normal conditions for 3 hours or more. That's a continuous load. A continuous load must be sized to 125% of its actual ampacity. So in this case, all in, by the time we add the 2 new fixtures that we're going to show you, we're going to be at about 12 amps. 12 times 1.25 is 15 amps. 15 amps is what we need to size the circuit and wire and breaker to as a minimum to properly serve this lighting circuit in a code compliant manner. In this case, we're using 20 amp circuit, 12 gauge wire. That's what all of our circuits are. That's for simplicity, that's for material simplicity, installation simplicity, but also for expansion ability. If we add security lights, we could pick them up off that same lighting circuit and still have room to grow. Now, all of these lights are LEDs, but the prevailing fixture that's very cheap in cost for an application like this is still a fluorescent fixture. So we did a ballast bypass. That's not the only way to do it, but in my opinion, that's the most efficient and reliable, long-term, most durable way to do it. And we have a video on that in detail. Check the description. This shop was full of T12 fluorescent lamps. Toxic, inefficient. One lamp uses about 96 watts of energy. So that's almost 200 watts per fixture. To refeed that, we would need 2 circuits to do the same amount of work with a lower quality of light. With fluorescents, we would have the flickering and we would have the startup time. Now that's something that's really nice with the LEDs, is if you get a LED that has a startup temperature around 0 degrees, when you walk out into this unconditioned shop, flip the switch, those LEDs will come on full bright instantly, as opposed to about 1/8 brightness with a warm-up time of about 15 minutes like fluorescents. Now you do have to watch out, not all LEDs are created equal. In addition to that, the ballast, the point of failure and inefficiency. The ballasts put off a lot of heat, particularly when they get ready to fail. They can actually melt themselves and the associated wiring. I've encountered that way too often. So we're going to use half the energy. We're going to have almost double the light. We'll have instant on. We'll have lower maintenance costs. So we tackled the lighting portion of our off-grid building, 2,500 square feet, by securing LED strip fixtures to the structure of the building. A couple pointers and tips about how we executed on that. So we routed MC cable following the building structure, securing it and supporting it within every 6 feet. In this case, we used jiffy clips and self-tapping screws. That's a code compliant installation, closely following the finished surface of the building, closely following the building structure. From this point, after entering the first fixture, we were able to run continuously through the fixture to every successive fixture, with a couple exceptions. In this case, we had to jump between fixtures with further MC cable and connectors in order to offset around the building structure. Here's an example of how we suspended the fixtures between structural elements. There's a 1/4-20 beam clamp, 1/4-20 all thread that we cut with a bandsaw so we avoided boogering up the threads. We've got a nut on the back side of the fixture with a washer, and then on the inside there's nut and washer as well. And so we are able to maintain a good, clean, linear flow of light. We're going to hang this fixture, it's all prepped and ready, over our workbench area here. We're coming 2 feet off the structural wall. That's probably going to hit the edge of our workbench nicely, such that we will not be casting a shadow by placing the light behind us, casting a shadow right onto our work surface. Don't want to do that. We also don't want to push it too close to the wall, because there's going to be things hanging above the workbench, and potentially even 12-inch deep shelves with cans of WD-40 and spray paint and cold gal. So what we want to do is bring 24 inches off. We're going to illuminate right above our workbench so we've got a good bright surface. This is going to be a critical space for battery assembly, for inverter commissioning, all kinds of technical processes. We want it to be very well lit. We're going to pull our switch leg. Rather than bringing it off the switch, we're just going to bring it out of the nearest fixture, slightly shorter run, feed it through both lights, and we're going to energize the workbench lights with the main overhead lights. We're not worried about efficiency because we already have high efficiency. We just want ease of lighting. One switch at each door turns on everything. All right, so we are terminating our MC cable in this fixture. You've got to get those anti-short bushings in there. I highly recommend it. I usually install my MC connector first into the fixture so it's fixed and it's not moving on me. Unless I've got a difficult to reach location, then the connector goes on the cable first. Either way is acceptable. Just take advantage of what assists you the most. Connector out for me, just so I can get it. That, my friends, is a 2-screw single barrel MC connector. So I'm going to bring in my cable without knocking anything off. It's kind of precarious. In the back side of this fixture, I used a knockout in the fixture so I didn't have to drill anything out. And it's fighting me right now, so I'm going to get rid of that center plate to ease my wire entry. Secure that so my cable doesn't go anywhere. All right, and I'm not going to terminate this until everything else is ready, because we have other work being done in here, cleanup work, and when I shut off the lights, I want it to be quick to execute this and turn them back on. Keep everybody lit up in the meantime. Put this back in. Now, I would not use zip ties in a place where you're going to be subject to UV degradation, but we won't in here. So what I'm going to do is use 2 of these quickly available zip ties because I don't have longer ones with me, and I'm going to slip them through . one thing that's important too is that you ground each individual fixture. See, the end plates, they're metal pieces connecting the fixtures end to end. And in some cases, it was a little bit sloppy because of how the fixtures were machined and the play. So we put in an accessory self-tapper. Now, all of these fixtures are directly connected to building steel. But here's the thing. Fixture to fixture and the connections that we have are not rated for a proper ground path or grounding connection. For instance, the fixtures are enameled. So if you secure something to the fixture, unless it's at the point in which it is intended with machine thread screws to provide a grounding path, then you can't reliably depend on that being a true grounding path. It may function, it may tone out, it may read 120 hot to fixture, but you've got to do it according to the manufacturer's directions in order to ensure a compliant ground. Because if someone climbs up here and gets shocked and you did it the old-fashioned way and you're sitting on the seat in court, guess what? You're getting sued. Look at that. That little yellow right there, that got pinched in between the housing and the plate. When the plate swung into place, that's a real problem waiting to happen. That thing's going to see 120 volts, the full ampacity of one of these tubes, which is 45 watts, so just over a third of an amp. Not much, but it's going to be enough to trip the circuit if we don't fix it. All right, so full disclosure, because we're electricians and we feel comfortable around electricity, potentially too comfortable, this was our temporary power feed. Cut the end off an old dilapidated extension cord and wired it in. But look, we do have a ground, guys. Don't throw too much shade our direction. So I'm going to disconnect our power. There it goes. I'm actually going to cap the extension cord. That's where the power feed is coming from. And I did that live just for you guys. But now I'm going to go ahead and unplug it. All right, that thing's going in the trash. We're done with it. So this is my hot feed to the lights, and it was a direct wire hot to the lights, and that was just temporary. So at this point, this truly has now become my switch leg to the lights, like it should be. We can get more into that in another video. But this is the switch leg, just double checking, make sure nothing's being backfed, nothing squirrely is happening, because we're transitioning from a pre-existing power source that's all cobbled up. We've got a real interesting video on one of the, what we call farm wiring. Pre-existing power to new power. We don't want anything getting crossed. It gets real ugly when things get backfed. The chance of shock goes way, way up. So at this point, I'm going to make up the switch. I've got a 4-square box that has a total of only 7 conductors in it, plus a raised cover that's going to give me a little extra space. So I've got plenty of room to work with. I want some nice long conductors. This white is a neutral, so I'm going to untwist my incoming cables. This white is also a neutral. All right, so neutrals get the nice solid pre-twist. A red wire nut. Tan would work as well. I'm done with them, so I'm going to tuck them as neatly as possible in an efficient manner to the back of my box. Done with that. Secondly, I'm going to deal with my grounds. What I'm going to do is, some of y'all really like the pigtail. In our jurisdiction, that's not required. I'm going to strip back a midsection. I'm going to take that midsection and I'm going to wrap it around the ground screw. That ground screw did not come in the box. Our warehouse team adds those with every metal J-box that they send out the door. That's a prefab in the warehouse. Really like that improvement we've made recently, as opposed to fumbling with parts on the job. But that raised hump in the box, that is intended for that purpose. Then I'm going to take and peel back a midsection here, closer to the end, and that's going to become my grounding connection for the switch. My switch is going to be in this orientation, so I'm going to be mindful of that when I'm securing my grounds. I want it to all lay nicely and neatly in the box when I'm done. Oops. Number 1 square drive, wrapped around that green ground screw, being mindful that I don't accidentally make a connection there. So I'm leaving the insulation on either side of my ground wire just for a little extra caution. Now, grounds together. So this is a 3-way switch, which there's a lot of common misconception around 3-way switches. It is a 2-position switch. You know what, at one time, I think I recall being told why it was called 3-way, but I completely forget right now. So if you know, drop it in the comments section and educate us, educate me. I love to learn, learning every single day, no exceptions. Now this is a little bit long, so I'm gonna cut all 3 of these short. Those are my hot and my travelers. I'm gonna put the shepherd's hook to the right. There is a place in the handle where you can do that as well. Boom, that makes a nice clean hook. You don't want to make that too tight, or you can't get it around the screw, too loose, and it doesn't wrap the terminal well. Oh, my red in this tinted light looks like brown, which is close to black, which is hard for a colorblind electrician. So I am going to be mindful that my switches, when they're both in the down position, the light is off. Oh man, I can hardly see which is which here. I've got to get my switch leg to the light on the oddly colored screw. See, I have brass, and I need the oddly colored screw to be my switch leg. Travelers go on the other 2 terminals. All right, so we're going to get all that tucked in there. I'm working it as I go so things lay in smoothly. I don't want anything to be jammed or crammed. That's about where that switch is going to sit. I'm going to break off the top. There's a score line there. And get rid of that. And that. I don't need these mounting screws. That's for a traditional box style. So those go. And then some people would be really insistent about wrapping the device. That's not a code requirement and it's not enforced in this jurisdiction. I'm not going to wrap it because this is going to be fully enclosed, and the only time this cover comes off was when the power's been de-energized. It's not grabbing yet. There it goes. This is called a 4-square box. It has 1/2 inch and 3/4 inch knockouts around the perimeter, and this would be a raised cover, a 4-square raised cover for a switch. They make them in all kinds of configurations. You can get these in Decora, which would be like a GFCI shape, receptacle, and any combination between the two. You can get them for 240 volt outlets. You can get them for side-by-side duplex outlets, dedicated outlets. This is an electrical industry universal kind of application. All kinds of useful, necessary, prevalent applications. All right, we're almost ready to throw the breaker. Just a little cleanup, that's it. So what I've got now is My jumper from this fixture to my workbench fixtures is almost complete. I've grounded with a ground screw to the fixture, and now I'm tying in my electrical connections to the existing hot and neutral connections. The circuit is de-energized. I'll bring my wire in, match it up end to end with the existing conductors. I'm using a red wire nut, still appropriately sized for the job at hand. And, ooh, beautiful tug test, nice. All right, now something that's a little bit different on this fixture is actually the row of fixtures. And what we've done is we've run THHN, that's a different kind of single strand fixture. So 3 individual spools, green, white, black, were set up on a wire axle. And those 3 conductors were pulled all the way down this strip of lights as if it was a conduit. And then at each junction point, we wired in. Now, having to cut the wire, strip it back, wire nut is a little bit labor intensive. The only reason we did that instead of using my favorite type of connector, link found in the description, for this application is because we're relocating our shop this week. It's like turmoil. It's like heart transplant on a trauma patient. Whew. Deep breath. So we couldn't lay our hands on the parts easily. The whole warehouse team plus outside help is totally preoccupied this week. I think the dust will clear within a couple of months and we'll have a total system ironed out, lubricated for this new facility. But for right now, we're using wire nuts, cutting and splicing, and check out the description. It's a little cumbersome with these sheet metal fixtures to get everything to just lay in beautifully, but you kind of need it to, because each part is dependent on the other part in order to piece together the jigsaw puzzle and keep it all together. It's pretty lightweight stuff. So these are spring-loaded tombstones. So on that end, I'm going to align the pin, depress it, find the slot, and then give it a little test. You can see how much flex there is in these LED lamps. Man, these things are flexible. Depress the pin, align it on this end, make sure it's caught so it doesn't fall and shatter. We chose to use LED lamps because we have got so much more light. We have got literally probably 8 to 10 times the lumens that we had in this space before. Now we have more fixtures as well. But foot for foot, fixture for fixture, we've doubled our light. We have less than halved the amount of energy that we're using. We have gone from a failure rate of every few months with these old fluorescent lamps to 50,000 hours of, hopefully, flawless operation. Our strike time on these lights is absolutely beautiful. Like, this is an unconditioned space, more or less right now. It's not insulated, although we do have a heater hanging over in the corner. But it's gonna be 0 degrees sometimes when we walk out here to start a project in the morning. We're gonna flip that heater on, and these lights are going to illuminate immediately as opposed to the fluorescents, which will take like 25 very long painful minutes to get up to any kind of meaningful brightness in that kind of temperature. So this project, all in, planning, procurement, execution, cost us about 2,500 bucks and 4 man days. That's our cost. If you're hiring it out, it's going to cost you more than that. You'll probably be in the 6 to 10K range. If you're doing it yourself, your straight material costs are probably going to hover around $1,000 to execute on this. We did rent a scissor lift to expedite the majority of the fixtures and some of the other things we had to do inside the shop. So we paid for a week-long rental on a scissor lift because our most valuable asset is our electrician and the labor that they provide. We've got to move that along as quickly as possible, but this could be executed with a buddy off a 12-foot ladder. Doing it alone with an 8-foot fixture gets pretty cumbersome and tiring very quickly. In this building, now that it's complete, we are going to be executing on off-grid projects. If you have a favorite van lifer who provides quality products and finishes, tag the channel. We'd like to collaborate because we've got projects in the queue now that we're going to be turning out and bringing to you. Subscribe to Electric Pro Academy for real skills to make real money.